My name is Mike Leighton, and I'm a software developer at Meta. And today, along with my colleague Matt, I'd like to discuss MobileConfig, which is Meta's internal tool for the authoring and distribution of some of the world's largest applications. So today, we're going to cover kind of configuration at Meta. We'll look at an overview of MobileConfig. We'll deep dive in some of the design and implementation. And finally, we'll close out the talk. So before we jump right into MobileConfig, we need to take a step back and look at the configuration products that we use to drive our web development. So we have things like feature flags and A/B testing. And what these do, they allow us to control how we release software, and they allow us to control the runtime behavior of our software. And they're designed for server environments. So they work very well with a single version of the application. They run on uniform and powerful hardware. And the configuration changes are nearly instant because this is running inside of our data centers. Now, the way that we use these configuration products is something like I have on the screen here. If we want to release a new feature, we put it behind a configuration value. And then we can use things like feature flags to control who gets to see that feature. So maybe we just do it for, maybe we just display this feature for a small amount of developers. Maybe we display it for everyone at Meta. And then once we get the feature where we want, we change that to an A/B test. And that A/B test allows us to determine if this feature should be released to the public or not. And then finally, we can either release it to everybody, or we decide we're not going to go with that feature. So really, configuration is critical to the agile software development at Meta. So when we started doing mobile development, we wanted to bring those features with us, but it's a much different environment. We have many different versions of the application. We need to run on limited resources. So these devices are not nearly as powerful as our servers. And these are not running in data centers. These are running in people's pockets. So there's a huge delay in propagation. But what we did was build an SDK for each one of our back-end configuration systems. And this is very pragmatic, but it had a large number of drawbacks. First, it takes a large amount of engineering resources to build these. Mobile developers need to be trained on how to use each one. And if you want to change from, say, a feature flag to an A/B test, then you need to change code inside of your application, which can take time to release. And the problem actually compounds because you're not just dealing with iOS, we want to deal with Android. And actually, we don't want just Android and iOS, we want to have all of our AR and VR operating systems as well, including other apps like Instagram and Facebook. And that's where MobileConfig comes in. MobileConfig is a cross-platform SDK that runs on all of these different apps and platforms. It provides a unified developer experience, and then it communicates with our single MobileConfig evaluation engine that runs on our server. And that evaluation engine will allow us to select which different backend particular configuration value belongs to. Let's take a look at MobileConfig. So at its heart, MobileConfig is a remote configuration system. And that means that it allows us to change the runtime behavior of our apps by using configuration, not code changes. And we use it in a number of different ways, from A/B testing to feature rollouts, as well as things like capacity control and personalizing experiences. It's actually pretty difficult at Meta because of our scale. So we have a number of different languages we need to support, everything from Java to Objective-C. Our largest application has more than 10,000 parameters. And we make more than 1,000 configuration changes daily. And MobileConfig is really critical to the way that we work. We need to be able to move fast and change software quickly. And these are the largest applications in the world. That means that when we deploy a configuration change, it's going to maybe more than 2 billion people. So what does MobileConfig look like? At its heart, we provide a key value pair API to our developers, which is simplistic for them to use, but it also is diverse enough to allow us to tie to those different backends. Every config has a name and a set of parameters. Every parameter has a name, a value, and a type. Developers can then change these values, and they change inside of the applications. And these values are specific to the user or device that MobileConfig is running on. And what I mean by that is, it could be different for each and every user. And we generate these values through something called evaluation. Evaluation is the process of taking configuration values and taking user context and generating values for a particular user or device. Now, I have an example up here on the screen, MyConfig. MyConfig has 3 parameters, and parameter 1 is tied to a gate. So when we take the user context, we're going to pass that to our gating software, and it's going to run a set of simple rules. If version 1 of the application return true, otherwise return false. And then parameter 1 for that user takes on the value of either true or false. A/B testing works the same way. And the nice thing about MobileConfig is our developers can start with a gate and then change it to an A/B test later on. Now, none of this would be possible without our client-side library. And our client-side library is actually a thin client. That means that we don't run evaluation every single time that we read a configuration value. We actually run it on application start and periodically throughout the day, and we run it in our back-end servers. This allows our client library to be highly optimized. And it means that our developers don't need to cache the configuration values they read from our API. They can go to our API each and every time, which enables a number of features that we'll be talking about later. One of those features is things like disaster recovery. All right, so that's an overview of MobileConfig. I'm going to turn it over to Matt, who will talk about the design and implementation.
Thank you, Michael. I'm Matt from Meta's MobileConfig team. A lot of I'm just said. Before we delve into the designs, let's review some key requirements associated with MobileConfig, which will help us better understand the necessity of the designs. There are many engineers using MobileConfig in our company. We can broadly classify them into 3 kinds. The first group are mobile developers. They call MobileConfig API to control various app behaviors. Their primary concern is the ease of use. They prefer to use MobileConfig AI as a single interface and unified on all mobile platforms like Android, iOS, and React Native. They want us to hide all the backend and the data syncing details for them, so the API is lightning fast, and they can call the API at any place, anytime. And the second user group are feature owners and data scientists. They design configurations and A/B tests for the products. They need to update a config value and then expect be quickly propagated to large scale of users. They also often need to check the value distribution of a config for validation reasons. Lastly, they like all MobileConfig values to remain consistent through a user session. For example, we never want a color of a button turn from red to blue in the middle of the session just because MobileConfig did a data sync. The third user group are app infra engineers. They are all for the overall efficiency and the reliability. So they want MobileConfig has a low overhead on all kinds of resources. And in addition, a config change can just change the app behavior like code change and sometimes introducing bugs. Like an engineer might just roll out a shiny animation for better user engagement, but it turned out to slow down many low-end devices. Or we change the title of a page to some more funny words, but it turns out to be offensive in some other culture. So how to detect, block, and reverse such bad configs will be critical. MobileConfig proposed several designs to answer those requirements, and I will pick some of them to cover today. And the first one is our local storage design. MobileConfig API always read from this storage, with some other threads periodically syncing remote settings into it. As mentioned by Michael, the storage uses a highly compact flat buffer format that condenses all the config values into arrays. We can memory map and read this storage directly without parsing, which helps to reduce the app start latency. Moving on to the API call size, We use code generation to generate symbols for each of the mobile config using current project. These symbols are essentially integers containing bits as the index to get the value from the arrays. These integer symbols can not only help to quickly locate the config value from the arrays within just a few memory hops, but also hide the feature and code names from the production release, so that not only makes the binary smaller, but also less hackable. Yes, we do have hackers mess around mobile config and try to exploit hidden app features. Lastly, mobile config storage is immutable. Any newly synced data will always result a new copy, and the config is tied with the copy on its first read, so that ensure the config value remains stable throughout the user session. Next, let's discuss a related dilemma and the solution to it. The dilemma is, for a freshly installed app, the local storage is completely empty. Then should the app start wait for the mobile config syncing or not? The app could choose to block the main thread and wait for the full mobile config syncing, ensuring everything is rendered with remote settings. However, this could test users' patience, potentially turning them away even before they've started. Alternatively, the app can just proceed to the first UI without waiting for mobile config, and just render it with the default values. But this could make the UI looks really old, like from 3 years ago. Despite all of this can be resolved in next cold start, it's still a pretty suboptimal experience. So we used to have each app using mobile config pick one of the two poisons based on their tolerance level, until we find a better solution called partial fetch. The idea is simple. We leverage the fact that only a few % of configs are needed at startup. Thus, for fresh start, we can initiate a lightweight request only fetching for these early access configs, then alongside another standard request for the rest. Such partial fetch exhibits less than 20% of latency compared to the full fetch, so that we can render the first UI with remote settings, as well as with minimal wait time. The subsequent functions that require access to more mobile configs are likely to happen after the full fetch, so that they are also fine. What's not that simple is how to keep predicting and maintaining the early access configs for thousands of different app builds and versions. And our strategy is to keep statistics and update the early access config list during alpha and beta testing phases, and then lock the list once the app moves to production. Next, let's review how mobile config validates its own logic after many optimization like the partial fetch. And the answer to this is called consistent logging. The idea is, at the time of mobile config return a value, a small set of users will report the readout value back to the server, so that, firstly, engineers can tell the global value distribution of each config. And then, in addition, the server will reevaluate the config and then compare its latest value with the reported value, so that we can come up with a consistent rate defined as the ratio of the past checks over the number of reports. At Meta, this might be our most important metric for mobile config's own diagnose. We closely monitor and build alerts around it at different levels. For example, in the left side chart, the top line is for the data we report back right after sync response. It has almost perfect score, denoting our network protocol is working as expected. The other line is the end-to-end consistent rate, comparing the value returned by our API and the server value. The rate is also high and good enough, about 99.7%. It's lower than the previous one, mostly due to the syncing interval and mobile config caching design. Then after mobile config's own validation, we'd also like to validate config changes submitted by engineers using mobile config. As mentioned, we have many config changes happens all the time. In fact, in Meta, we've seen more severe issues from config change than code change in the past. So how can we deal with that? In general, we always have two ways to validate a change, either being pessimistic, which means to fully test the change before deploying, or being optimistic, which means quick publication, testing production, and quick reversal on any found error. In our MobileConfig Canary solution, we used both approach. To be more specific, we first run a pre-land canary that lasts 4 minutes for a small set of users and looking for the most critical and reproducible regressions like app crash. If succeeded, we will land the change to about 1 million users and then run for more hours. And then monitor a broader set of health metrics like user engagement, newsfeed latency, etc. If all this passes, then we will fully deploy the change. In 2023 alone, Canary helped us to catch 40 severe issues before they could affect production. But occasionally, there'll still be some bad configs passing Canary and landed. In such cases, we need to firstly rectify the config value on server side, and then use a component called emergency push to eliminate the bad configs. Emergency push can not only accelerate the delivery of a config to target a user base by using a more expensive channel, but also support developer to specify a post-delivery action, like clearing the MobileConfig cache or even restart the app in background, so that ensure the bad config is totally gone right away. The lifecycle chart shows an example that the baseline curve shows with normal MobileConfig, normal MobileConfig syncing, 85% of users can adopt the new value after 24 hours. And then with emergency push, but without a post-delivery action, this improved to 92%. Then if we chose to also restart the app on delivery, this almost eliminated all the bad configs nearly instantly. To summarize, today we introduced a MobileConfig, which provides a unified API connecting Meta mobile apps with various configuration experiment backends, so that our developers can adjust the app behaviors rapidly at hyperscale. We also introduced our progressive data syncing design to solve both slow app start and stale configs. Lastly, we introduced how to support landing so many config changes in a fast and safe manner by using Canary and the emergency push. And that'll be all today. Thank you. We're happy to take in questions.
Thanks, speakers.